Hello everyone. I'm Parthiv and I'm a final year engineering student from Manipal Institute of Technology. I'm currently interning at Indian Institute of Science and I'm one of the volunteers for KCD Bangalore 23 and will be hosting this workshop for you. So this is the third edition of Kubernetes Community Days, but it's the first in-person edition. Scheduled for 2nd and 3rd of June at Nimhan's Convention Center, we're looking to make this a grand event. So if you've not already gotten your tickets, head over to tickets.kcdbangalore.com. This is one of the workshops in a long list of workshops being held before KCD Bangalore. Today, we are joined by Nizam Uddin from Tetrate, who will be taking the Istio 060 workshop. Istio is a key tool that helps developers and organizations monitor, connect, and secure their microservices without requiring changes in application code. As development moves towards a more containerized approach, this open source tool has grown in significance over the years. It has become one of the most widely adopted service mesh used in production. Now I would like Mr. Nizam Uddin to take over and proceed with the workshop. Sir, do you want to give the participants a couple of minutes to get their local systems running, or anything is fine?
Yeah. Thank you, Parthiv.
Yeah.
So, we will check the local system and everything, the environment participants are using. Okay. So welcome everyone in this workshop 0 to 60. I am Nizamuddin and I am working as a solution architect in Tetrate.io. Tetrate is a service mesh company. It is providing its own flagship product, Tetrate Service Bridge, for service mesh. Now, this workshop is 0 to 60 for Istio, and welcome everyone here. Now, this is me. I'll be the instructor for this workshop for all of its labs that we will cover here. Now, about this workshop. So Parthiv, you are asking about some minutes for wait somebody, some other participants, or should we start?
Yeah, so I see that we have a total of 11 participants right now. So if you are comfortable with continuing the workshop, it's okay, sir. Otherwise, we can wait for a couple of more minutes while the others get their local setup running.
Okay. So the thing is, in this workshop, okay, I'll come to the setup part. Okay.
Yeah, sure.
Let me go through like what is this workshop all about and what we will cover. Okay. So in this workshop, we will see installation and uses of Istio, and I'll explain the architecture, how Istio works, how in fact service mesh works, and some of its use cases, the key use cases what Istio provides. Okay. Now, as part of prerequisite, I am expecting all of the participants to have the basic understanding of Kubernetes, Docker container, and some basic Linux commands. Okay. Now, the duration is 3 hours. We can take 10-15 minutes break in between. And after this workshop, if you want to be part of the Slack community, then you can join the Tetrate community for Istio. Even there is one specific channel for Istio 0 to 60 workshop. Usually, if like later on the workshop, you have any query, you face any issue, then you can post your concerns there, then you will get reply over there. Now, in this workshop, the approach, what we are following is, this is lab-driven training exercise, where every attendee has its own Kubernetes environment ready, where we will be installing Istio. Then, yes, of course, there are a lot of slides also, but I'll try to spend minimal time over slides. And of course, at any time, if you face any concern, query, you can ask me. So in this exercise, the overall schedule is like, first we will see the lab environment. Then we will discuss about the Istio, what kind of problems Istio is going to address, some high level things. Then we will go through Istio installation, then various process of how sidecar injection works or how application is working under the hood. Then we will discuss in action its observability, its security, and the traffic shifting. Okay. Now, what I need from you is like simply you need to do git clone of this repository. I am pasting this, or let me do the git clone thing on here. So simply you can do git clone this repository on your local machine. Okay. So this is the location. This is this GitHub location where there is one artifacts folder. Okay. And inside this artifact folder, there are all required YAML files that we are going to use in the lab exercise we are going to conduct. Okay. Now, one more thing that we are going to follow. We are not going to use this the chat box here. Everything, all the steps are mentioned in this lab. So you need to do simply open this page. This is Tetrate labs.github.io for Istio-0 to 60. So here, this is the lab environment. So lab environment, it's simply, actually, this is a generic thing here. So it is talking about Google Cloud and some Minikube or whatever. But here, in our environment for this lab, the requirement for infrastructure is bring your own Kubernetes. So I am expecting that every one of you is having one Kubernetes cluster with you. Okay. Now I am going back to this lab environment. Then we are moving forward for the Istio installation directly. Now I am going to show you every step in action. Okay. This is the artifacts folder. Okay. What I have copied. Yes. So in this lab environment, if you will click on lab environment, go to the very bottom. And in this very bottom, it is providing steps for cloning this GitHub repo, Tetrate Labs, what I just pasted in the chat box, Istio-0 to 60.git. Then there is a directory, artifacts, and then it is simply saying remove the original folder and use only the artifacts. So yes, so this is that artifacts folder. Okay. Now I am here and this is my artifacts folder. Okay. Are we on the same page, everyone? Now let me run kubectl get ns. I just want, okay, this is rapture based solution. So I'll have to do login for my Kubernetes. Okay, login is already there. I have to refresh the role only because what I am using is a role-based authentication for my EKS cluster. So I'm running again kget ns. So this is my clean cluster. There is no trace of Istio installed, nothing here. This is a fresh cluster. Okay. One more thing, when you are having Kubernetes cluster, so your utility command is kubectl. So usually we create alias for this kubectl. If you want to create alias for kubectl, then this is the script. Okay. Simply, it is saying that alias k is equal to kubectl. Then if you are using bash rc, then it is putting this information inside the bash rc file. Okay. And then we are good. Okay. So kget ns is my showing my Kubernetes cluster, which is clean at this moment. Now, what I am going to do next is I am going to install Istio. Okay. What is Istio? What is this all about? I'll come to that later. But first, what I am going to do is I am going to do some basic things about Istio. Like I am going to set up the Istio installation. So here, environment lab. Okay. So this is set up your environment. Okay. So we have done our lab environment ready. Is everyone on the same page? You are able to do kubectl get ns and your Kubernetes cluster is working fine. I'm expecting everyone to be on the same page. Now, lab environment is ready. Now, we will come to Istio installation later. Let me explain a bit about the Istio. Okay. So, first, I'll explain what problems our current industry is facing, how those problems are going to be tackled by Istio, and then all about Istio. So if you see, like, this is the era of microservices. All of the organizations, or you can say most of the organizations, are migrating from monolith to microservice. And when organizations are migrating to microservice, they are using mainly Kubernetes for microservices there. Okay. If people are there, let's say in AWS, someone maybe uses ECS, but again, there is Kubernetes also. So we can assume that Kubernetes, or we can say the containerization thing. So most of the organizations are using containerization, either maybe ECS if someone is in AWS, or maybe Kubernetes. Okay. So to achieve the microservices thing. So if I read this problem statement, then this IT shift to modern distributed architecture has left enterprise unable to monitor, connect, manage, and secure their services in a consistent way. Why this situation is arising? Because when solution is monolith, then there is one VM running, multiple applications are running over there. Some applications are communicating locally. Some are communicating over the virtual machines. Virtual machines are having IP addresses. So communication is taking place via IP addresses, or some service discovery mechanisms are there. But when it comes to microservices, then life of pod is very small. It comes up very fast, goes very fast. So again, the communication among the pods in Kubernetes, there are thousands of pods and n number of Kubernetes clusters. So when it comes to cross-cluster communication, when it comes to cross-service communication, then there are the needs of security, like if traffic leaving one service reaching to other, if that is secure in the way or not, or are we properly able to monitor the entire traffic communication or the security thing, or this entire connectivity. So this is the problem when Istio is not there. So if I am going down with the problem statement, then yes, in modern distributed architecture, we are migrating with container-based services. Environments are very much dynamic, and there are various networking components when we are using containerization thing, whether Kubernetes or anything else. So like I summarized these things monitoring. So let's take a bit deeper. So when we are deploying our microservices, then we are not able to see the metrics in terms of who is accessing what. We are not metrics in terms of the performance metrics, and we are not able to see the logs of access logging things. And again, the tracing it is like when one service wants to communicate a service that is down the road after 5 to 7 services, then we don't know how much time which services consumed in the path, or which services return what error. Okay, so this is called tracing. We will see this in action. Again, the connect is like service discovery, how that thing is done, how that thing is getting done. Then resiliency is when service A is communicating service B, then there is a possibility that service B is bearing some load, and because of that load it returned 503, 504 something, but actually that service is running. So there must be some resiliency to putting retries, figure out outlier detection, circuit breaking, timeouts. So I'll describe these terms when we would be implementing them. Then again, the load balancing at client side. So again, the problem statement in terms of managing is when we are doing L7 routing. L7 is application level routing. So we need fine-grained control for like, if let's say I want to say that the request, if bearing a header XYZ, should route to this service, or if requests that are having header something else, then they should route to some other. So this kind of fine-grained control is provided by Istio. And again, the policies on request. So with the help of Istio, we can say that service A is allowed or service B is not allowed, or service A can only put 5 requests per second or 10 requests per second. So these kind of features we are currently struggling. If Istio is not there, then we are implementing all these things, whether the application logging or like tracing or this fine-grained control inside the code. Again, so for security point of view, when it comes to the service-to-service authentication, this thing is not there. We have to manage this inside code. And when L7 routing is taking place, so this is application to application, and if application wants to know who is accessing me, then again we have to do this hard code in our code. So these are all problems. Like how can we secure the communication? How can we manage? How can we see the observability? Currently, when we are doing the advancement of our monolith to microservice, and microservices are too much in number, then these are some problems. Now, come to Istio. So what is service mesh? So service mesh is like when we are, service mesh is a concept, and this concept is achieved by the implementation of Istio. And with the help of this service mesh, we can tackle all of the issues what we had discussed about routing, securing the traffic, securing the mesh, or traffic shifting, observability, anything. With the help of mesh, we are going to tackle all of those issues. So now the real player inside Mesh is the Istio. Let's discuss what is Istio. So again, Istio is a platform to monitor, secure, connect, and manage services consistently. How does it achieve it? Because it provides a platform, right? There are several other players within this platform who leverages us to achieve all of these features. Now let's install Istio in our lab first, and then we will come to this. So let's follow this. Install Istio installation lab. Install Istio. So first, what we are going to do is we are downloading Istio using this command. This is Istio version 117.2. I have copied this command using this copy button, and let me check which Kubernetes cluster is this. Okay. Let me see what all is there. Okay. Now. Okay. So what I have done, I have downloaded this Istio 117.2. Okay. Let's see Istio. So it has number of files. So I believe that all of you have downloaded this folder using this command. Okay. Now, what we need to do is simply cd inside this folder. Next. Istio provides one utility. Its name is IstioCTL. Sometimes we call it IstioCTL. Okay. So what we are going to do is, so IstioCTL is here. Inside this folder, there is a bin. And inside this bin, this IstioCTL utility is here. So I need to keep this IstioCTL utility in my path. Okay. So what I need to do is, let me check if it's, what I need to do is, let's follow this doc. This doc is saying, create a bin directory in your home, then copy this IstioCTL to this bin, okay? And then put this IstioCTL in your path, okay? Export path is equal to home bin, then path EOF, source B -rc, then you will run IstioCTL version, okay? Okay, this is my older version. Let me replace my older version with this newer one. Or you can put this inside your user local bin something ls user local bin IstioCTL move cp bin. Now you see, after following all these steps, because it's your style of putting any utility or any binary file in your system, either you put that in any specific folder and add that in the path, or simply push that in your user local bin, USR local bin, this path. Okay. So now my IstioCTL utility is 117.2. My next step is that this is a pre-check command provided by IstioCTL. So what does it do? It provides a convenient pre-check command that can be used to inspect a Kubernetes cluster for Istio install and upgrade requirement. Okay. So simply run this command. No issues found when checking the cluster. Okay. So what does this IstioCTL do? Internally, it is providing you, it is referring to your Kubernetes cluster. Okay. So whatever your kubectl is pointing to your current config of kubectl, kube config of kubectl, the same kube config this IstioCTL is pointing. Okay. So is everyone able to see this green checkbox? I believe everyone should be seeing this green checkbox. Okay. So this green checkbox means that your Kubernetes cluster is compatible with this IstioCTL version. Okay. Now next move is install Istio. So installation is very much simple with this IstioCTL command. Simply say IstioCTL install. That's it. Okay. Then it will ask you like yes or no. Then we will say yes or no. One more thing. Istio provides a different installation profiles. Let me show you. So these installation profiles are like default, demo, minimal, remote, empty, and preview. So when we say Istio install, IstioCTL install, and we pass the this profile name. So if I do not pass anything, the profile name is default. Okay. These are the profile I can pass demo profile or empty. So the meaning of this is Istio, it installs three components. One is Istio egress gateway, ingress gateway, and IstioD. IstioD is actual the control plane of Istio. Istio ingress gateway, it provides a mechanism to allow the outbound traffic to come inside your mesh. Okay. And Istio egress gateway is what when we want to egress or wants to communicate external world, then all of the traffic from your mesh will route via this gateway. So I'm not covering the external gateway part. I'll cover only these two, ingress and IstioD. So for my case, default is sufficient. Okay. So that's why I have not passed anything here. Let me install this default. It is asking yes, no. And it is also mentioning that these components, Istio core, IstioD, and Istio ingress gateway will install. I'm saying yes. It will take few minutes. Cool. If you run kget namespace, then you will see one namespace is created there, and its name is istio-system. Okay. And inside this namespace, if I check the ports, then here you will see two ports, IstioD and Istio ingress gateway. Okay. And these two ports should be running. Everyone should be here at this moment. We are on same page. Okay. Now, let's follow the doc. It is saying that go ahead and run and verify install. IstioCTL verify install. Let me run this command, IstioCTL verify install. It will return everything green. Okay. So what it is showing that all of the CRDs are successful there, all the components are successfully installed or not. Cool. It means that Istio is installed and verified successfully. Now, what is the next command? It is saying that verify if any namespace is there. Then we have checked that two ports are running in our namespace. So far, what we have done, we have installed Istio in our installation in our Kubernetes cluster. Okay. Are we on the same page? I believe everyone should be there. Now, we have covered this lab, Istio installation. Now, let's discuss the Istio. Now, what is Istio? How it works and everything. Okay, shall I proceed? Okay. So the thing is, forget about Istio here. Let's start the beginning when there is no Istio. Let's say that in a normal Kubernetes cluster, we have deployed two services, service A and service B. Okay. When service A wants to call service B, so every service has some ports behind it. So there would be some ports behind service A. There would be some ports behind service B. Okay. So when service A calls service B, then let's say service b.svc.cluster.local:8080, then service A will get the results. In this case, service B does not know who is service A. Service A is happy that, okay, I have got the result, but service B is feeling awkward that who has accessed me, right? So this is the current communication when there is no Istio. Okay. Now, when we do Istio installation, what Istio does? So Istio does so in Kubernetes, whenever we launch any pod, so pod has one container, or it depends on your application, it can have many containers. So in one pod, Istio injects one more container. This it calls sidecar. So the definition of sidecar is which runs along with or which runs in parallel. So that's why we call it sidecar. Ultimately, this is running, it runs Envoy proxy. So Envoy is a very lightweight proxy, and its sole purpose is to design for service mesh. And this is ideal fit for service mesh. So what Istio does, it injects one sidecar envoy along with the ports in service A and along with the ports in service B. Okay. Now, if service A wants to communicate, with service B, then, so how communication will happen? Pod of service A will initiate a request. Okay. That request will route through this envoy sidecar. Then this sidecar will make a call to this service B. Within the pod of this service B, IP table rules are reconfigured in such a way that any incoming traffic will route via this sidecar. Okay. Then this sidecar will route that request to the application running inside the same pod. Okay, let me rephrase. Pod A has two containers, let's say Nginx and the sidecar. Pod client, any client and sidecar. Pod B is Nginx and sidecar. When any client here wants to call application B, so it initiates a request. Its IP table rules are configured in such a way that any request which is originated by your application container would be routed via the Envoy container, the sidecar container. Okay. Then that sidecar container will interact with this sidecar of pod B. Then this Envoy sidecar will send that traffic to the container of B. Okay. So this is how Istio injection does. Applications do not communicate directly with one another. They communicate via their sidecars. Hereafter, only sidecar to sidecar communication will take place. Okay. We will go deep diving into this. So now how the things are working. So think like, I have given you an example of only two services. Assume that there are 10 services, okay? C, D, E, F, G, H, I, J, K, okay? And with every service, every port, there are sidecars. This sidecar is running along with the pod, and there can be hundreds of pod for one service. Okay, it means hundreds of sidecar. Now the question will arise how this sidecar will know the configuration, uh, how the sidecar will do the service discovery, how other configuration like routing configuration or security configuration will be provided to these sidecars. Here is the role of IstioD. IstioD runs as a single Docker container here. This is the IstioD Docker container. Inside this IstioD Docker container, there is a process running, pilot agent. Okay, so in the latest Istio, what Istio community has does, it has merged all the components of pilot of Istio, the control plane. Earlier, there used to be separate components, like one component was for config management, one for certificate identity provider, one for validation. So I am taking the older model just to explain how internal things are working. Okay. So like IstioD is for configuration management, and its one component is Galley. Now this component is running as a piece of code inside the IstioD. Its major job is to validate the incoming config, whatever we are pushing inside Istio. Okay. Second is pilot agent. Its role is to propagate those config to all the sidecars in your cluster. Okay. And along with the configuration distribution, it distributes the policy also. So one is what we apply just to configure our mesh. These are some policies for security policy, routing policy, and there are certain configurations. Configuration for the information about the mesh components, some internal configuration. Okay. So this is the role of Istio. Now, third component is Citadel. Citadel is like we have to provide identity. Let's say that when we are setting up HTTPS communication in a normal server, we simply, what we do, we deploy a certificate in our server. So what client does? Client simply say HTTPS, that returns the certificate, it verifies that with the CA, okay, certificate is okay. And then it does, it's a TLS communication. But in case of Istio, what it does, it provides identity and identity certificate to each Envoy sidecar. Okay. And when mutual TLS will happen, then they will have to possess their identities that, okay, I am this and you are that. So this identity mechanism will be used to identify who you are. And again, this will be used in security context for authentication and authorization, whom we are going to authenticate or whom we are going to authorize for what verbs or what operations. Okay. So this is all in one piece, service A, service B with Envoy, with application, this is TOD. Its role is config validation. This is pilot for distribution and policy. Citadel is for identity management. Okay. Instead of looking as a big picture, let's see the small picture. This is your service mesh where Istio is installed with service A is there, service B is there, and IstioD is installed. Okay. This is from the top view. Now, like what I described earlier, when service A wants to talk to service B, then it will talk to Envoy first, then it will talk to Envoy of service B, then it will verify the identity, who is the caller. Then again, since it's a mutual TLS, so the sender identity will also be checked, and then both are happy. The communication is successful, and then they will start interacting each other. Okay. One more thing, all mutual TLS termination, identity validation, verification, it happens between sidecar to sidecar. Okay. If I am restricting that identity of this client A should not be allowed to access B, that would be dropped at this envoy only. Your request will not hit your application. Okay, so it's sidecar to sidecar communication. So finally, when your sidecar will say that, okay, everything is verified, then client would be successful to communicate with server B. Okay. Now, yeah, these are all steps B answers. And this is the complete picture of how Istio control plane works. Like this is Istio control plane, underlying some control APIs are there. This is service A, this is envoy proxy, and this is how it is communicating with service B with some TLS certs, some policy checks with config data. Okay, now let's come to the lab. We will deploy our one of the application. Okay. I am not explaining the extras. This is how some manual sidecar injection will take place. Like I told you, there is one envoy. So there are two ways. Either you inject that sidecar manually, or you can do that automatic. So you can go through later inside this lab because we have very short duration in which we will have to cover everything. So let's come to the application. So there are two applications that we would be using for inside this Istio demonstration. In the official documentation, there is one book info application that is widely used book application for Istio demonstration. But there are a number of applications there for different purpose. But we will keep things smaller just to understand our logics. So there are two applications, the web front end and the customers. So the customer service exposes a REST endpoint that returns a list of customers in JSON format. And the web front end, as its name suggests, calls customer to retrieve the list, okay, which it uses to render to the HTML. Docker images should be public. And what we are going to do, we will install these applications in the default Kubernetes namespace. Okay, because inside this GitHub, what I asked you to copy, the default namespace is mentioned, the default. Okay. Before this, like I told you, we need to enable the automatic sidecar injection. So how automatic sidecar injection will take place? We have to attach a label on the namespace. Okay. So our namespace name is default. So what label we have to attach is Istio-injection is equal to enabled. Okay, so let me check kget port and default namespace. There should be nothing. Yes, inside default namespace, nothing is there. K describe ns default. There is only single label. Let me attach this label over here. Namespace default is labeled. Let's describe it again. So you will see this label is attached. Istio-injection is equal to enabled. Okay. Now let's deploy the application. So in your artifacts file, there are two files there, web-frontend.yaml and customers.yaml. Let me take a quick walk. It is creating a service account. Its name is web frontend. Then it is deploying the application replicas 1. Okay. And so internally, it is setting one environment variable for customer service URL, so that things remains quick. Then it is creating a service. Its listening port is 80 and target is 8080. Then the customer service, again, it's creating a service account. Then it is creating a deployment object where it is deploying one image, and again it is creating a service and exposing it to 80. Okay, let's deploy this service. So inside, so inside artifacts, like I told you, there is one, what was the name? First services web-frontend.yaml. Okay, so let's move to our artifacts folder, cd artifacts, and here execute these two commands. It has created service account, it has created deployment and created service. Now deploy the web front-end service. Okay, now check get ports. So yes, give it 2-3 more seconds. It's initializing the port. Okay, are we on the same page? We have deployed our application, and why it is showing 2 by 2? Because like I told you, it has automatically injected one sidecar container. Let me show you kget ports this -o YAML. So you will see that it's a very long file. So this is pod and containers. This is your customer container. Then again, it is deploying one proxy sidecar container. Okay, so it has its name is Istio-proxy. Okay, so this is the sidecar container, and like I told you, inside that pod, it changes the IP table rules to route incoming and outgoing traffic within that pod to route in such a way that it goes via sidecar only. So these are IP table rules. You can go through this extras thing. So it is explaining all the rules and everything in detail, how routing is taking place. Or if you want to go more deeper, how the pod networking is taking place, then you can consult IP table utility, how IP table utility works. Okay. So here we are, we have confirmed that these two pods are running. One more thing, like this is something more deeper, like how did it happen that we enabled a label only at our namespace that enable Istio injection, and internally Kubernetes API server has injected a new container Istio proxy in that. So it's so Kubernetes provides some mutating webhook configuration. So when you will run kubectl get mutating webhook configuration, so what it does, like Istio revision tag, Istio sidecar injector. You see, this is a mutating webhook configuration, and what it will do, it will capture. So what happens whenever we apply a Kubernetes file, kubectl apply in the file? So some requests are put to Kube API server. Okay, those requests are validated, and then that is stored inside the etcd server that is running behind the Kube API server. Then so this is internal to Kubernetes. Then scheduler places those resources. Okay, so like this. So if any operation is create, resource is poured, what you need to do is So a lot of configuration is here. You can go through this later. So in a nutshell, that it is using a mutating webhook configuration for sidecar injection. Okay. You can study how mutating webhook admission controller works for Kubernetes. It is a very long topic. Now we have launched 2 services. Okay. Now what we need to check is we need to verify if both of these services are running properly or not. So just to check it, I need to trigger curl command, and we need something within my Kubernetes, because as of now, my both of the services are running inside Kubernetes and we cannot access them from outside. So let's run one sleep service. Okay. And what it will provide us, it will provide us one sleep get host sleep pod. Okay. And capture the name of sleep pod to an environment variable. Okay. So let's follow this. Okay. So this sleep pod variable as the name of our sleep container. Okay. Because every time I'll have to refer this sleep pod. Now, what I need to do is I'll check my customer service if it is returning the desired output. Yes, I am able to see a JSON response with the name of customers. Okay. And let me check how my web front end service is doing. Let us trigger this. Okay, I'm able to see one HTML response. Okay. Okay. So this application installation is done. Are we on same page so far? I believe these are straightforward steps. So I believe everyone should be able to do this thing. You don't need to do anything specific, just to follow the steps mentioned in this repo. Okay, so we are done with the application. Now, what we have done, in my default namespace, forget this Kubernetes service because this is for my Kubernetes. We have deployed 2 services. One is customers, one is web front end. Okay. And you see the external IP. External IP is none. Only cluster IP is here. Okay. It means that I cannot access my web front end from the external world. Only within the Kubernetes I can access it. Like I showed you, via sleep service, I can only access it. Now, what I need to do is I need to expose this service to the external world. Here we go, the usage of ingress. So ingress is, as its name suggests, ingress, it runs again the Envoy as Envoy proxy, same Docker image version, same everything, but its implementation is different here. Okay, so we are running ingress gateway here as an Envoy proxy. Now, what we do, we will create a service object of type load balancer. And since I am using EKS, so it will create one load balancer in AWS for me. And if someone is using Google Cloud, then it will provide you again same NLB there with IP. Or if you are using some Minikube or anything, then you can use Metal LB. So I believe this thing should be there in your Kubernetes cluster. Okay. So what I am doing, I am simply saying is hello.com. I'll hit the LB. Then that request will go through this ingress gateway. Then it will hit my web front end. Okay. So yes, likewise, envoy from here will communicate the envoy to this service. Then, like I explained you, here envoy to envoy communication will take place. So let's go a bit deeper. What can we say about Ingress? Ingress is one Ingress gateway pod, okay, that runs in the Istio system namespace. So, like I told you, I installed the default profile of Istio, okay, where in default profile, it automatically installed one Ingress gateway. You could have installed any other profile where Ingress is not there, then you will have to install your own Ingress there. All the configurations are provided in Istio documentation. Now, what we will have to do, Envoy proxy is simply there in Ingress gateway. We have not mentioned anything, nothing is there. So what we'll have to do, we will have to configure a gateway on that Ingress. Okay. The concept of gateway is like I'll expose, this is my host name, this is my port. Okay. And so host name and port are exposed on that gateway. Okay. Now, third part is the routing configuration. Once that gateway is saying that, okay, this host is exposed to access the service behind this Ingress gateway, now the the actual player comes in, the routing player. Where will that request route? Which service will serve that request? Okay. So this hooking or this mapping of routing will be configured by this virtual service. Okay. Let's come to the lab of Ingress gateway. Here we go. So objective of this lab is to expose web front-end service to the internet. I have explained this when you install Istio. In addition to deploying Istio in Kubernetes, the installation also provisioned an Ingress gateway. And I showed you the pod inside Istio system namespace of this Ingress gateway. Now let's check a service also. Okay, so here we see, if you check the service in Istio system namespace, then it has created, when we installed this Istio, it installed the Ingress gateway. It created a service object for me of type load balancer. Okay, its external IP is this. Cool. If, like I told you, if you are using GCP, then instead of this long DNS name, you will see one IP address here. And if you are using Metal LB, then again, you would be seeing one IP address here. Okay. So this is my Ingress gateway load balancer. Now, if you will hit this Ingress gateway, so what it is doing, it is taking the DNS name or the IP address of this load balancer in this variable. So let me show you how this thing will work. So let me do echo. If anything comes here, it is blank. Why it is blank? Because this exercise is designed for Google Cloud, and Google Cloud assigns IP to load balancer. But this Amazon AWS, it assigns host name. Now let me do echo gateway IP. You see this thing. My gateway IP environment variable is having this DNS name of my ELB. Okay. So what you need to do simply, if you are using AWS, instead of IP, edit it to host name. Okay. Oh, someone asked question. So like I explained, IstioD is the controller, and I explained the internals of IstioD, what it does. As of now, Istio is running as a single Docker container, okay, and single process. And Istio core is, yeah, all that is Istio core, what I explained. Okay, thank you. So yeah, this is for AWS guys. Okay, now what we need to do, like I told you, we have already one ingress gateway running. What we need to do is we need to make a hole inside this ingress gateway. Okay, if I hit this, where is my gateway? This. If I do curl HTTP, this, I'll not see anything. Or if I say 8080, I'll have to see what port it is exposing. It is not returning anything. You see, because there is no hole, no gateway exposing anything on this ingress gateway. Okay, so my next step is to make a hole inside this ingress gateway, and this is how it is happening. So this is one Istio networking object, networking.istio.io. Its kind is gateway, and I am giving it a name, front end gateway. Selector field is on which deployment, on which Istio ingress gateway you want to punch this hole, or you want to apply this gateway configuration. Okay, because in production there can be number of ingress gateways, number of load balancers can run there. Okay, what I am doing, I am simply saying that this is my port that I want to expose on this gateway. Its protocol name is HTTP and protocol is HTTP, okay, and host. As of now, I am exposing extra host. Why? Because I'll have to make DNS mapping and everything, so it will make exercise some complex. Okay. So let's apply this. I am here inside my artifacts. Okay. So apply this kubectl apply -f gateway.yaml. Now let's check kget. GW is the shortcut for gateway object. You see it has created one front-end gateway. If I check it, what is there, then you will see the content, what I just explained, selector, server, and the port. Okay. I am believing that everyone is on the same page. Now, the next step, we have punched a hole inside this gateway. Okay. Let me run that curl command again. If we see anything, you see now it is at least returning something, but it will not go anywhere. When we will see the logs of this Docker container of ingress gateway, it will say that no route found kind of thing. Let me show you the logs. Get pods, not here, -n Istio system. So this is my ingress gateway. Sorry, -n Istio system logs -f. This it is not showing anything. Okay, we have just made a hole. It is not showing anything. Okay, let's configure the routes, then we will see. So kubectl apply. Okay, I have not explained virtual service, sorry. So this web front-end virtual service, what it is saying, I am giving it a name. This is of kind virtual service object. Name is web front-end, and host, I am exposing all host. One thing, this is a host list, okay? And where is that? This is again a host list, right? This is a list here. Like number 15 is a list. And again, this is a list. So this list should always be a subset or exact set of this list, because you cannot mention any extra host here what you have not exposed here. Okay, so let's say I am exposing hello.com and example.com. So you can only take either hello.com or example.com both, but you cannot take hello.com or pqr.com here, right? Now, gateways. So gateways means from which gateway this virtual service is associated. So like I am saying that this is my gateway, front-end-gateway, okay? And the request will be routed via this virtual service from this gateways, okay? Now what I am saying, any request coming from any host, simply route that to the destination web frontend to default SEC cluster local on port 80, okay? Let's apply this. I think I have applied this. Yes, I have already applied this. It is unchanged. Let's check if virtual service resource is created there. VS is the short form. VS is the short form of virtual service, okay? Let me see what is all there. So you see all host from this gateway, and this is the routing, okay? Now come to the next part. Yes, so this is a bit deeper. Like I told you, I have exposed Xtrick, not any specific DNS name. So if you want to do a specific DNS name, then you'll have to create DNS mapping with your gateway IP. And again, if you want to check with HTTPS, if you want to expose your ingress gateway as HTTPS, then you will have to set up TLS termination also. So this is for you to do exercise after this session. You can follow all the steps here. So this is what let me see. Okay, nothing is here. So let's do one thing. I have not shown you. Let's run curl. You see, earlier curl was not throwing any output, but this time it is throwing output. But let me see the actual output. Echo $this. This is my DNS name. HTTP:this, and this is 80. Okay, I'm specifically mentioning 80. Oh wow, I am able to see my front end, web front end from my browser. Okay, we have exposed our service via ingress gateway to the external world. All right. Now we have covered ingress gateway. Now come to the observability part. Guys, just give me 1 minute. I'll take one sip of water. Okay, I'm back. So observability. Istio provides a lot of internal observability tools. What it inbuilt support is the Envoy, the sidecar, what we are injecting along with all of our pods. So you have seen that any traffic that is incoming to your application is going via sidecar. Okay. Any traffic that is going outside of your application, that is going via sidecar. It means that uh, Envoy has all the information who is accessing your application, or where your application is, or whom your application is accessing to, right? It means that Envoy can provide you a very useful information about its observability, like how many requests were successful, or what time the request took place, what time request took to finish, or if service is returning 404, 502, 503, anything. Okay. So it inbuilt exposes Prometheus endpoint. So if you guys are a bit aware of Prometheus, then Prometheus is a pull-based monitoring tool. Okay. So we simply say to Prometheus that, okay, this is your endpoint that you need to monitor. Then what Prometheus does, it on a fixed interval, keep on scraping the endpoint exposed by this application. Okay. So what does this endpoint expose? It exposes all the metrics. Okay. Now all the metrics would be fed to Prometheus. And again, there is one more tool. So Prometheus is for your observability monitoring for 5xx or any red metrics, read, accessed, or uh, like the endpoint metrics, um, or like the endpoint times, or yeah, we'll see them. And then second part is Zipkin. So Zipkin provides tracing. So like I told you, tracing is from point A to point D. There are two more services, service B and service C. So how much time service B took to complete its request, how much time service C took, how much time service D took. So from point A to point D, the complete behavior, the time consumed by every service, or if any error is returned by any particular service, then via tracing you can see that, okay, at this moment or at this service, my request failed. Okay. Or in a total path from point A to D, we are doing some performance optimization. Okay. That my request should take place only within 30 milliseconds. But somehow I am getting its response in 80 milliseconds. So I can check which component is consuming more time. So this is all about tracing. Okay. So Zipkin is one component that is used for tracing. Okay. There is one more component. This is access log service provided by Envoy. Like I told you, Envoy has all the data, who is accessing, right? And whom the application is accessing. All the to and fro of all the request is captured by Envoy. So these requests, access requests, are generated as logs, and there are many observability tools in markets which uses this access log service uh, to create very nice descent graphs for monitoring. Okay, so one way of monitoring observability is via Prometheus. One way is via this access log service. Okay, so there is one open source tool. Its name is Skywalking. So we are using this tool also. So Skywalking is completely maintained by Tetrate, and it's a real original maintainer. He is also part of the Tetrate. So Tetrate provides its flagship solution TSB, and there we provide observability using this access log service via Skywalking. Okay, let's go to the observability part, how Istio is doing its observability. Okay, so like I explained, Zipkin, yes, so Zipkin is a tool for tracing, and one more tool is Jaeger. It is pronounced as Jaeger. Okay, one is Prometheus. Grafana is for graphing purpose, and Kiali is for visualizing the mesh, how traffic is communicating. You will see a very nice UI of traffic communication, live service to service communication, or how traffic is routing from one service to other. Okay, let's apply everything. So what we need to do is we need to change directory to our Istio folder where samples and within add-ons. Okay, so I am here inside artifact. So go back from artifacts, and if you will do ls. So earlier when we installed Istio, we downloaded this directory Istio 117.2. Okay, let's go inside Istio 117.2, then samples, then add-on. Let me follow this: samples, then add-ons, samples, then add-ons. Okay, now let's deploy each of these items. First, I am deploying Zipkin. After the, okay, sorry, my session is, let's apply Zipkin. So, okay, get pods, not here, which namespace? I'll have to see, get, maybe in Istio system, get pods minus n, Istio system. Yes, you see Zipkin here inside Istio system namespace. Okay. Now let's deploy Prometheus. Let's deploy Grafana. Let me clear my screen. Let's deploy Kiali. Now let's check all of these ports in Istio system namespace. So we are able to see Zipkin is up, Prometheus is up, Grafana is up, Kiali is on the way. Let's see why Kiali is not coming up. Kiali is up. Okay, all of my ports are up. Are we on same page, guys? Yeah, these are straightforward steps. So what you need to do is simply copy and paste and deploy. Now, so Istio CTL utility, it provides a nice way for UI to check the dashboard. So your CTL dashboard. So IstioCTL provides a command for dashboard. So if you want to check your Grafana dashboard, simply say IstioCTL dashboard or simply D, then the name of the component. Let's say Grafana, Jaeger, or Kiali, or Prometheus, or Zipkin. Yes, it is showing Skyhooking, but we have not deployed Skyhooking. Okay, so let me open the Grafana. IstioCTL dashboard, Grafana. So inside localhost, welcome to Grafana, and then inside Grafana, so click on this icon, the dashboards, and inside this dashboards, you can click on browse. So if you will click to browse, there is one dashboard folder, Istio, and inside this Istio, there are 5, 6 more folders: Istio control plane dashboard, mesh, performance, service, awesome, workload dashboard. So let's see the control plane dashboard. So yes, it is showing us a very nice graph. So deployed version 1.17.2. You can check on this tooltip. Then resource usage. So we can check CPU, etc. Pilot push information. So this is all information related to the Istio pilot. Okay. Then envoy information, webhooks. Okay. Then in other dashboard, performance service dashboard. So let me see what this service is showing. Client workloads, service workloads. So incoming request. So yeah, a lot of graphs are here. Okay. So this is how it is showing the all the Istio related component and your services. Istio service. Services customers.default service. You can choose your web front end here, and then you can see all the metrics of your web front end service. All right. Likewise, so this is histograph, and likewise there are one more Kiali graph. Okay, I'll have to change. I'll have to change. Let me control C. If I say Kiali, so it is launching Kiali for me. So what it is showing graph, select namespace, I'm saying default, and then empty graph, because there is no load as of now. That's why it is showing empty. We have one more step, how to generate load. Okay, so generate a load, because until there is a load, we will not see any information inside Kiali. So there are many tools. So there is one tool, its name is Siege. So Siege is used for load generation. Okay, so there are many ways to install Siege. Start, configure, build, make, install, generate this Kiali dashboard, and we will see things. So here we go. So either we normally install Siege with apt get API package manager. However, given the cloud shell ephemeral nature, anything stored outside our home directory will vanish after the session. Okay, so the thing is, if you want to install Siege via apt-get, then it's okay. Or if you want to install on your current directory, then let's follow this. So I'm using Mac machine. So let me install this using brew install Mac. It's on your choice, what mechanism you want to follow. You can build from the source also, siegelatest.tar. Okay. So let me open one more window. I was not expecting this much time. Okay. So let's see why you say minus help, or my spelling is wrong. SIG. Okay. Siege is here. Let me put some load. So generate load, it is saying that Siege delay this on your gateway IP. Let me, let's kill this. Echo dollar gateway IP. Gateway equal to this. Okay. Let me run this, seize this. Okay. Let it run. We are putting load. Now let's come to Kiali again. And let's launch Kiali dashboard. Here, if we go to, so here is the thing. So namespace is default and Istio. So this is how it is showing the traffic. This is my Istio ingress gateway. Then it is sending traffic to the web front-end service. It is saying all host asterisk. Then what is this V1? V1 is the level of my deployment. Okay. When I deployed this web front-end service, so I deployed of a V1 type of node. where is my web front end? So if I see this web front end deployment, so this is version v1, okay? So why I explicitly use v1? Because I am going to show you the traffic shifting also from version v1 to version v2. Here, now we can click on this. This is HTTP, and you can see like these are the information related to your 5xx or 4xx performance. Okay. Then if I go to application, it is showing there is one customer sleep and web front end application. If you will go to workloads, okay, these are my workloads, deployment, app is equal to customer version v1. And then these are my services. Okay. So this is all information what Kiali is showing. This is Istio configuration, what we deployed, web front end. This is what we deployed, the virtual service. Then if I show you the front end gateway, then you can check that configuration here also. Okay. So this is all about the observability part. I have not covered tracing. Let me see tracing also. Service name. Let's put customers.default. Okay. So what it is showing? Yes. So ingress gateway, let me click on show. This is how your tracing is showing. It is like I told you, request. It will show you the time consumed at every level. Okay. So ingress gateway, front end, then customers, then this is the customer service. Okay. So you can see all the spans here. How much time, what request, here, which service, etc., etc. Okay, guys, I'm not going to spend very much time every detail about Zipkin. It's up to you. Okay. So in observability, Istio, in a nutshell, I'm summarizing it. We have seen Grafana. We have seen how Kiali is showing the runtime traffic, and we have seen how tracing is working. Okay. Now, this lab is covered. Now we are taking 10 minutes break, and we will start at 4:50, and then we will start the securing your environment. Okay. Okay, guys. Okay. So in these two sessions, one is security and traffic shifting. We are taking the security now. Okay. So this is about whole security, what I'm going to explain. So in Kubernetes, so like I told you, security is what? If we say someone that you are allowed to access this workload, okay, this is authentication. If we say that you are allowed to do these operations with these resources, then this is called authorization, right? So then we need identity to apply our policies, that who is you, who are you, right? So to define who are you, we need identities. So in Kubernetes, if we talk about plain Kubernetes, identity is service account. Okay. So if we want to assign any workload, any identity, then we create service accounts. So we attach service accounts to our deployments, right? So if you will check, then each service account is associated with one token, right? So that resource will receive that token, and that token will act as its identity. Okay. So this is Kubernetes concept. So likewise, here in Istio, it is using service accounts for Kubernetes for the identity assignments. The basic thing. On top of it, it is using one more framework for identity management. Its name is SPIFFE. So this is secure production identity framework for everyone. So this is a framework. So what it does, like I told you, whenever any pod comes up, okay, then Istio injects a sidecar in it. Along with sidecar, there is, like I explained, then there is one citadel that manages the certificates and everything, right? So there is one init container inside. Inside any pod, where Istio manages the certificate for that workload. So the workflow is like, whenever any pods gets created, first pod namespace gets created, then init container changes its underlying IP table rules, then one more palette init container, it creates the identity of the sidecar. Okay, it communicates first with IstioD, then it provides, okay, this is my service account, my namespace, and everything. So this is that SPIFFE ID, SPIFFE cluster.local. Then this is the namespace ns/default, and this is the service account. So this information is passed to IstioD. Then IstioD will issue a certificate while embedding this information inside that certificate, and that certificate would be of type X509. Okay, so like in any certificate, there is one SNI, like, okay, this is my domain name, example.com. Okay, so likewise, these identity certificates, they do not bear any SNI, but they bear one URI. URI is this SPIFFE ID. This is the name, right? And this is the identity. So this identity certificate, along with this identity, it becomes sorry, let me rephrase it. This certificate issued by IstioD, while having embedded, or you can say encoded, this identity SPIFFE : namespace and service account into this X509 certificate, then this X509 certificate is used as the identity certificate by that workload. Okay. This is specific to every pod. If in one deployment there are 3 pods, then this X509 certificate would be different for all the pods, though the SPIFFE ID would be same. Reason, those all pods would be running inside same namespace. They would, since they are part of same deployment, so they would be using same service account. In spite of having the same SPIFFE ID, they would be using different X509 certificate. It ensures that every pod, every workload, even that is part of same deployment, it bears a different identity. Okay. So this is how SPIFFE ID, SPIFFE framework does. If you want to study more about SPIFFE, so there is the link related to SPIFFE. Security, mutual TLS. There must be somewhere some link. You can Google it, how SPIFFE works. Okay. This is a general phenomenon. Let's come to this. Now, we have assigned identity to our workload. Now, come to the mutual TLS part. So this is a very important feature provided by Istio, the support of mutual TLS. Let's say two pods wants to communicate with each other. So in normal TLS, how things happen, this left box, this is the normal TLS. Server only poses its certificate, right? And usually when we deploy any HTTPS server, we deploy its server certificate on the server, right? When a client wants to access, then it simply says HTTPS, and then what it does, there are proper TLS handshakes, and in those handshakes, it returns its server certificate. Client verifies that, then it establishes a session. Okay. So in this case, in this total handshake, only server is saying that who I am. Server is showing its certificate. Certificate showing means server is showing its identity. Okay. So now onwards, instead of certificate, I'll use the term identity, right? So server is showing only its identity, that this is I, this is me, google.com. I don't care who you are, client, you can simply access me. But when we want to secure client server communication with mutual TLS way, then server will also request client to show its identity, who you are. Okay. So in this case, first client will establish a session, will ask server who you are. Server will provide its identity. Client will validate that, okay, I'm good. Then client will provide its identity. Then server will say that, okay, I'm good, that you are the one who you should be. It will establish this way, it establishes the mutual TLS, and then session key is shared, and then they start communicating with each other. Okay, so in a nutshell, in mutual TLS, both the parties will have to show their identities. Okay, in plain TLS, only server has to show the identities. Now, here is the thing. Now, let's say that in our ecosystem, there are two services. One, I have deployed the customer service. One, I have deployed the web front-end service. Okay, I am saying that anybody who wants to access my server is customer service, then it must follow the mutual TLS. Okay, this is one way. This is called strict TLS, strict MTLS. Then whoever is the client, it must follow MTLS. There can be a scenario that your client is out of the mesh. Okay, then in that case, it will not have its identity. Then how mutual TLS will work? So to support this scenario, there is one more mode. It is called permissive mode. So this is showing the permissive mode. Let's say you are having one legacy client, and these are two clients, client and server. Client and server both are part of the mesh. They can show their identities. They can establish mutual TLS, but the legacy client, it cannot. So there is no mutual TLS. It can follow only the TLS, the plain TLS, where server will be showing its certificate. So we are saying the permissive mode. Okay, I'll show you that in the configuration when we will be do the demo, and we'll be doing the demo. Okay, so there are two ways for authentication. One is strict, one is permissive. So yes, this is the name. If we are using strict, then your legacy client cannot access this mesh-based server, because this is a strict. Mesh-based server will say that, okay, show me your identity. But since it is not posing any identity, it will fail. Communication will fail. Okay. So this is the thing in text, what I have explained. Peer authentication is the mechanism to control communication between two services. There are two ways. One is permissive. Permissive is default, and strict. Strict is what both parties will have to show the certificates or the identities. We can apply this peer authentication either at any particular workload, like I showed you workload selector, we can choose, or we can apply this on entire mesh or any particular namespace or on any specific port. We will see how the application will take place of this policy. Okay. So this is the file. The object name is, the kind is peer authentication. Okay. This is of API security.istio.io. Okay. Kind is peer authentication. Metadata name, I am saying just a default. Namespace is who, like I'm binding this to one namespace and I'm saying that, okay, MTLS mode is equal to strict. So here is the deal. If I say name is equal to default, okay, with any peer authentication, default is a keyword and this is a reserved keyword. And I am passing a namespace. Then this policy, your authentication policy is strict would be applied to all the workloads within this namespace foo. Okay. And if I give any name here, let's say ABCD, then it is a generic. Then we will have to select, we will have to pass workload selector. Let's say here I am saying name is equal to default. Okay. But namespace foo, and I am, instead of applying it on any particular, on the entire namespace, I want to apply it on particular application, particular pod. Okay. And its label is app is equal to prod. So it is restricting it to only pod level instead of namespace level. Now here is port level setting. If you want to apply it for, let's say port level, then mode is equal to, you can say, there are three modes, permissive, strict, or disable. So I am saying that enable it for entire namespace, but disable it for a specific port 5000. So any traffic that is being served at 5000 by any of the service, then it is relaxing that from mutual TLS. Okay. So this thing was happening between service to service, right? We have discussed everything from service to service. This is service A, this is service B, and how mutual TLS or plain TLS is taking place. What happens that instead of service, any particular user is there. I want to restrict, I want to apply authentication on the basis of user. So this is called request authentication when we come to user. So what we do, again, I'm repeating that line again. We are applying security. So whoever is being authenticated, that must possess one identity, right? So identity in case of services in Kubernetes is service account, but in case of individual user, what is the identity? For identity purpose, we are using JOT tokens, Java, JSON web-based tokens. So JOT tokens are used as part of identity. Again, user can be restricted for any particular namespace or any particular workload. So these are all the features. So we are using JOT tokens. We can allow at mesh level, namespace level, or workload level. And we can also restrict users at the ingress level. Let's say that forward original token. So we can take that token via header also. So this is the configuration, request authentication, name, selector, why I'm applying this on my application, that is HTTP bin. So who is the issuer? So every JOT token is bearing a label like who issued that JOT token, okay? And that token also has JWKS URI associated inside that JOT token. Now we are going a bit deeper. So here what we are doing, so this is Istio Envoy filter. So this filter, what it is doing, saying that so like when we create any JOT token, so there are some metadata associated, like who is the issuer, who is the local jocks, who is the jocks URI, where is what, or you can assign there any key value labels. So we can say payload in metadata, or we can assign any role specific thing. So I am saying that if this is my provider and match, if this prefix is this, then provider name. So these are certain rules that this Envoy filter is using to authenticate that JOT token. So let's don't go very much in detail, because Envoy filter itself will take more than 1 hour to explain. So let me explain from top. Let's say that I mentioned that whenever any JOT token is issued, it bears its issuer field, its JOX URI, or certain labels. Let's remember only 3 things. Label can be key value pair, and I am saying that role is equal to admin. For example, I am assigning that user role is equal to admin or role is equal to reader. Okay. Now, when I am validating that user in my request authentication, so I can put validator on the issuer. That issuer should be this. I'll allow only this issuer who has issued the tokens to access my workload. Okay. Second, I can check if my token is expired, or when we create token, then there are also fields of generating audience, like whom this token will be going to used. Forget about it. And signature. So every token has its signature associated. It's again going very much deep. So these are certain fields. Let's say you can check token has token key, lots of labels associated, and in our verifier validator, we are matching with these tokens. Okay. And after a successful match is there, okay, then we will allow that user to access our resource. Okay. So this was the authentication. Now let's come to authorization. Authorization is again, if a user is authenticated that, okay, you are the one who can access this resource. Now, second part comes what you can do. Okay. Are we allowing you to only for GET request? We are allowing for post or delete or anything, right? So can a user send a GET request to path hello, or we are saying that authorization is happening via authentication, or vice versa, because sometimes we are not authenticating. We are saying this is open for public, but only for GET request, right? So we can do that also. So there are proper authorization policies that cover all these if-else thing, matching thing, validation thing that we will cover in our exercise. So there are 2 types of policies in authorization. So one is peer authentication. This is the kind resource I showed you. Second is request authentication. So request authentication is for users. Peer authentication is for the services. Now, authorization policies, let's say saying apply this policy on this app is equal to prod. This is my one workload running there. Okay. I am saying that resource request principal is equal to X-Trick. So request principal can be anything. So we will come to this later. We will see this. What is this request principal? Okay. So let's say that authorization policy again. Yes. So here inside rules, so you can go through inside Istio documentation about rules, because this rules list is very much long. It provides n number of from candidates who what we can pass. So let's see that for authorization, rules can be, let's say for source, principal can be, I can provide the name of my workload. So the workload identity is passed in such a way that first, this is my cluster domain. Okay. When I install Istio, we have to set the cluster domain. So usually cluster domain is cluster.local, whatever is the end. Uh, if you see your service DNS, then this is the service name dot namespace dot svc dot cluster dot local. So the last two word cluster dot local are the domain of your Kubernetes cluster. Okay. So the domain of your Kubernetes cluster, then namespace slash namespace slash namespace name. Okay. Then slash SA, then service account name. This is the complete FQDN of your this service account. This is the way how we pass service account. Okay. Then source can be particular namespace. It can be prod, or it can be request principal. Again, request principal is a keyword, or we can call it a label that we set in our JOT token. Okay. So these are the from candidates, what we are allowing. Okay. Now we have discussed from. Now let's come to the authorization policy, the two part. Two, operation can be method delete, path can be logs, or can be method get, path can be get, or operation requests port host, or we can apply them at port level. So in a nutshell, we can pass generic path also by applying extric. We can we can set path any specific path, or uh, we can set on the basis of the ports. Okay. Yes. So we have covered from, to, and the when condition also. So when condition is when request dot header. Again, these values are fetched from your JOT token. So let's a simple example. I told you that if JOT token is bearing a label role is equal to admin. Okay. So I can allow here when role is equal to admin. That's it. Okay. So when JOT token is bearing role admin, then allow this for request access. Or you can say that if source IP is this, or remote IP is this, or request header is this. So these are all we can pass in when condition. These were rules from to when. From is who is allowed, to where to allowed, when the condition. Okay. Action can be deny, action can be allowed, or action can be custom. So custom is uh, like for certain rules we are saying allow, for certain we are saying deny. So we can customize the rules, and so it's instead of setting this deny or allow for all, customized way provide way to set uh, allow or deny in a customized way. So what we have covered, we have service to service peer authentication. So for authentication, we have covered service authentication. This is called peer authentication. For user authentication, the term is called request authentication. And for access control rules, we have covered authorization policies. And again, we have seen that who is from, who is to, and when is when. Okay. Let's come to this lab exercise. So again, what I have covered in theory, some text is mentioned here. So here is the thing. Okay, so in observability, I want to show you um, that log padlock icon. Okay, see that. So here is the thing. So we have seen that web front end will send request to the customer service. Okay. So what we are going to see from like this event, like this, we are going to see this. If any third party, which is not part of the mesh, if that can communicate with our customer service or not. Okay. So let's create a namespace, some other NS. Okay. And I told you earlier that any namespace will be part of the mesh only if we attach that label Istio-injection is equal to enable. So we will not add any label on this namespace. Okay. So let's deploy sleep service in this other NS. And we will have to go back to our the artifacts folder. The artifacts. Okay. Are we here, everyone? Because sleep service deployment file is here inside artifacts folder. Okay. I'm going to delete this. Another N. K minus N. We get pods. See, there is sleep pod running one by one means only one container is running. There is no Istio sidecar. Means this is not part of the mesh. If you see in default namespace, 2 by 2. 2 by 2 means they are part of the mesh, and Istio proxy is also there. So we have seen the pod. Let's take sleep pod, pod IP inside its variable. And at the same time, what it has does it has executed kubectl exec minus other ns minus another ns sleep pod. So it has tried running this customer service. So you see, customers.default we are accessing. So this is the service we deployed in default namespace, the mesh service. Okay. This service, this is our customers.service server. And this is my sleep service inside other NS that is not part of it. Pardon? Hello? Hello?
I think one of the participants accidentally unmuted their mics. I think you can carry on.
Okay, okay. So it means that we have seen by doing kubectl exec to this sleep pod that we just launched outside of our mesh, and we are able to curl the pod that is running inside the mesh. From outside of the mesh to inside the mesh, we are able to communicate. Okay. Now come back. The output should look like a customer JSON format. Okay. Now, so what we have seen that this is called the permissive mode. Okay. Because outside of the mesh component can access the inside mesh. It means the mesh component is accepting non-mutual TLS communication also. So non-mutual TLS in mesh term, we call it plain text communication, plain text request. Okay. Now, what we need to do is I want to do a complete lockdown that my mesh component should only accept mutual TLS traffic. So what I'm going to enable is strict MTLS. Okay. So name is default, namespace is default, then MTLS mode is equal to strict. Okay. So So let's see that there should be some MTLS strict file. Let's apply this kubectl apply -f MTLS strict.yaml. Actually, this line is not mentioned here. Okay, enable strict mode. This is not explicitly mentioned here. Yes, this is not explicitly mentioned here. Or so let's apply it. So now let's check if peer authentication is applied. So kubectl get peer authentication. So you see a default name file is here. So let me show you. This is my peer authentication file. Its name peer authentication object name is default. Namespace is default. Okay. And I have said that it should be strict. So I can see that a file, object, peer authentication object of name default is applied. If I say -y so mode is equal to strict, applied here. Now I have locked down my mesh for this default namespace that it should be strict MTLS for all the resources. Okay, because here you see I have not mentioned any resource name here. I have not mentioned any workload selector. So this policy would be applied on the entire namespace. Now let's run that kubectl exec command from that other namespace sleep pod. Okay, let's run that again. And this time it is saying that received failure, connection reset by peer. Why connection reset by peer? Because the server is asking for mutual TLS, and mutual TLS process says that server is asking for certificate, but client is not able to provide certificate. That's why server is saying that, okay, goodbye. So that is called connection reset by server or by peer, it is calling. Okay. So here is the deal. When we did not apply strict MTLS, when plain text requests were allowed, or in other words, permissive mode was there, then the component which was outside of the mesh, it was able to allow. It was able to access this server. But when I applied the strict policy, this client could not access this. Okay. Okay. Now let's come to the authorization policy part, where we will see we will allow only specific services to communicate with other service. Okay. So capture the name of sleep pod running in the. So what we are going to do here is, at the moment, any container can, for example, call the customer service or the web front-end service. So the thing is, I have allowed only the authentication service. Okay. But I have not allowed any authorization service. So let me delete this policy. Let's allow access for all. Okay. Instead of the mutual TLS. I'm removing mutual TLS. I'm keeping it plain text. Just for my authorization demonstration. So here, the thing is, in authorization, what I am going to do is allow only this client service to access this server service. Means web front end can only allow the customer service, but any other service should not be allowed. Okay. So let's see how the thing is. So let's first capture the sleep pod that is running inside our kubectl get pod in the default namespace. Okay. For default namespace, we are not passing any namespace. So default, let's run this sleep pod for default namespace. Now let's try accessing the customer service from the sleep pod. Okay. And let's call this web front-end service also from this sleep pod. So here is the thing. A get O in default. So this sleep pod, this is inside default namespace, and this sleep pod is also part of the mesh. It can access my web service, it can access my customer service. Okay. Now, what I am going to do is I'm going to place certain restrictions. So we wish to apply a policy in which only web front end is allowed to call customers, and only the ingress gateway can call web front end. Okay. So what we are going to do is we are going to apply one authorization policy, allowed customers from clients, and I am going to apply this on customers. So whose authorization I am tweaking? I am tweaking the authorization of customer service. Okay. And what I am saying that from resource, action is allowed. From resource, source should be this service account. Service account name is web front end. As I told you, service account is the identity. Okay. And this is how we mention identity in Istio. Okay. So what I am saying that only this principal name is web front end service account is only authorized for this customer service. I am not applying here any verb or any other action. I am just showing you one-to-one. Okay. So let's apply this policy to our cluster. auth policy customers.yaml. A apply -f auth policy customers.yaml. Okay. Okay. So we have applied this. Let's check if this policy is applied there or not. So what we will have to do, we will have to check the authorization policy resource. This is not mentioning K get authorization policy. Okay. So we applied the name was auth policy. Name was allowed customers client, and this is allowed customers client. Okay. 31 seconds ago. So we have allowed one policy. Now let's try accessing customer service again. Okay. So let's go back to our this was my sleep pod, and I am throwing a curl command for my customers policy. Okay, RBAC access denied. So RBAC access denied. This is expected because allowed authorization policy that is saying for customer service, that customer service can only be accessed by web front end. Okay. And if you want to check what was my no, I'll have to get that. Code dollar gateway IP. See, so I am hitting my ingress gateway. Ingress gateway is then routing to web front end. Okay. And this is my customers list. So web front-end service is allowed to access customer service, and we can see the result. But at the same time, from the sleep pod, I am not able to access my customer service because it is not allowed there. Okay. Now let's go back to this. So the thing is, what I have shown with this authorization policy, I have applied this authorization policy to allow from only the web front end. You can apply the same policy for your web front end, saying that only Ingress Gateway pod can allow the web front end, okay? So that your chain from Ingress to web front end to your customer service. So only one-to-one mapping is there, okay? So what you need to do is simply make a replica of this service, change the name of here match levels workload selector, and then change your principal instead of web front end, change it to your Ingress Gateway service account name. Okay, this is a to-do task for you. And you can follow here. What is the name of your service account if you want to apply it for your Ingress Gateway? So service account name is Istio Ingress Gateway service account. Okay. Then it would be a complete one-on-one mapping of your authorization. So here this security exercise is finished. Now, yes, we have covered its lab. Now the next exercise is the traffic management. Okay, what we have seen is who is allowed and what the allowed candidate can perform, and how, if what kind of mutual TLS or authentication authorization, those things are there. Okay, and we have seen that service to service authentication and authorization. If I am allowing any service, then that can only access. If I am blocking someone, then that cannot allow. Now, here we go with the traffic management. Traffic management is about the routing. Okay, so routing means we created one virtual service, right? Let's go back to the virtual service. A get vs -o YAML. So what I did, I said, okay, from this gateway for all the host, route to this. So this is a very straightforward, the basic virtual service that I used here. Routing decisions are L7 decision, right? And you are aware that at L7, routing can be based on the prefix, the URI, right? It can be based on your port. It can be based on any specific header, okay? And here, the routing for any specific service can be done for like for traffic management. We can do that if one set of application that is having version V1 and other set of the same application I am deploying with version V2. Then if I want to say the canary deployment, canary means if I want to the load balance of traffic, let's say 10% of traffic should go only version V1 and 90% of traffic should go on version V2. So all these kind of decisions, they take place on this routing configuration. And in Istio traffic management, we are going to see, and there are two and only two components that we are going to use is virtual service and destination rule. Okay. So again, virtual service is for configuring routing rules, and destination rule is to configure targeting endpoint and some like subsetting options of creating subsets of endpoints. Like I told you, version V1 and V2, because how Istio will know that there are some subsets. So there must be some mechanism to declare that, okay, the labels version V1 should fall in subset V1, or whatever you call it, ABCD subset, or labels with version v2, they should fall on subset PQRST. Okay, so that task is done by the destination role. So how to route the request? I'm just going through from the plain Kubernetes. So let's say that there are two Kubernetes services, service A and service B. Of course, there are two deployments, and those two deployments are running pods, and these pods are running inside mesh. So there would be one sidecar also. So this is the structure of two services so far we are discussing. So let's say that service A wants to communicate with service B. So how this communication will take place? Envoy from this pod A, is pod of service A, will hit the endpoint of service B. Okay, and if you are aware of Kubernetes, then every service object in Kubernetes has endpoints. Okay, and what are those endpoints? Those endpoints are the IP addresses of the pods, which are constituting that service. Okay, so request from here will route to the endpoint. Endpoint is this pod. Okay, again, like I told you, request would be captured by Envoy, and then Envoy will forward that request to service B. Then reverse path would be followed. Service B will respond to Envoy, and again, forget about this service object. Then it will go to the Envoy, and you will see the result in service A. Okay, so this is the path. Now, here, what I am running, only one version of service B is running there. Okay, let's say that you are deploying any new component, you are releasing any new component, and you want to test specific traffic. That, okay, let's see that I am pushing a new release. I want to test this release. Let's say for 1% of my real traffic, I want to route to my new deployment. And let's say 99 should be there on the older release. I don't want to affect my older customer. I want to, I can take chance on 1% only. Okay. Or this is percentage-based routing. Or I say that if some requests are bearing a header, that header value is equal to key is equal to value. Okay. Then it should route to my older version. And if header value is key is equal to value 2, it should route to my newer version. So this is the thing. This is service B, my older deployment. I simply said this is my version V1. And of course, when its pod will launch, it will be a version V1. When I am going to deploy other deployment, so it will be a version V2. Then its pod will have version V2. One thing is common. The common thing is app. See, whenever we create a service, we have to mention a selector field there in Kubernetes, right? So that selector field selects the pods that will make the endpoint of those service. So you see app is equal to service B. So app is same in both the deployment, but I'm only changing the version number. Version is equal to V1 and version is equal to V2. That's it. Okay. Here we go. I am creating a destination rule. Destination rule, I'm saying that for my this service, service b.example.cluster.local, create two subset. The name of my first subset is V1, and club all of the pods inside this subset which are bearing label version is equal to V1. Create other subset, its name should be V2. Attach, like club all of the pods in this subset which are bearing version V2. Okay, so it will create two subsets for you. Now, what I am going to do is in my virtual service, I'm simply saying that route destination host subset is V1. I'm saying weight is equal to 70%. And to the same service, to the same to other subset, but weight should be 30%. So here, like if if I am sending 10 requests to this service B, then 7 requests out of those 10 requests will route to my V1 and 3 requests will route to my version V2. Okay. So this is my traffic management. Now this is the picturization, how things are taking place. So when I create this destination rule, so these 2 entries are created in Istio configuration, then 70% to subset V1 and 30% to subset V2. Okay. Again, when this pod A is sending any traffic, like hitting this service name, service b.example.cluster.local, then like I told you, 70% are routing to V1, 30% are routing to V2. Okay. So now it is explaining the usage of destination rule. So first we have seen it helps us to create subsets on the basis of labels of different versions. Apart from creating subsets, it provides us a way for load balancing. It provides us a way for traffic policies. So let's say that I want to, so by default, the load balancer mechanism is round robin. Let's say that I want to change my round robin to list connection, because in some use cases, connection established can be longer duration connections, or my requests are connection oriented requests. So round robin will not work there, right? Because maybe some connections are being held for longer duration by certain pods. Maybe there can be scarcity of connections in connection pool in that pod. So I can prefer list connection or random or pass-through. So connection pool setting can be of TCP type, or we can set this on HTTP. We can set outlier detection. So what is outlier detection? Let's say that in one service, behind one service, there are 10 endpoints, okay? And those 10 endpoints, of course, those 10 endpoints are 10 pods, right? And those 10 pods may be scheduled on different underlying nodes, EC2 nodes or your Kubernetes nodes. So there can be a situation that any pod may behave some abnormally, like it starts throwing 504 or 503. Reason can be maybe the underlying Kubernetes node is bearing a CPU resource crunch or memory crunch, or maybe that pod is overwhelmed with the request. So there can be any scenario. So what I have seen, I sent a request, I received 503. I sent another request, I again received 503. So if your user is saying 503, then this is a bad experience for user, right? So what Istio provides a mechanism of outlier detection that if your any particular node returns 5xx, let's say for 3 consecutive 5xx it returns, then I can say that remove it from the list of healthy endpoints, okay? And remove it for 15 seconds or 30 seconds. Then after 30 seconds, put it back. If it again returns 5xx, maybe that pod is choked and it is not recovered, or it is permanently starts failing. So second time, it will again check, okay, it is again returning 5xx. So second time, it will mark it unhealthy for a duration of the duration I set, let's say 15 seconds or 30 seconds for eviction period, and the number of its health check. For first time, it was marked for 30 seconds. If it is not recovered and checked in second time, then it would be marked for second into 30, like 60 seconds. For third time, it will check. If it is again not recovered, then it will be marked for 3 into your eviction period. So it will be kind of exponential eviction period for that pod. Okay. So this way, I am protecting my client from the abnormal behavior. Okay. So apart from outlier detection, there are retries also. Retries is, let's say that I said my outlier detection should be 3. If 3 consecutive 5xx are there, then remove that endpoint. Okay. But my client had initiated only one request. So for first request, he has seen 5xx. Okay. He will send other request, he'll see 5xx, he'll send other request, he'll see 5xx. So what is the benefit of Istio? So Istio provides a mechanism of retries. So internally, I am saying that retries 4 times. If I am assigning outlier for 3 times, then I am assigning retries some greater duration, some larger number than my outlier detection time. So that for, let's say that I have set outlier detection for 3 times. So in those three consecutive 5xx, that particular node pod would be marked unhealthy, right? Since I have made 4 retries, so on 4th retry, that request would be served by other endpoint. Okay, and I am assuming that my other endpoint is healthy, so it will serve that request as healthy request. So outlier detection along with retries, they work hand in hand. Okay, so here I am protecting my client seeing any 5xx because my retry policy is covering the outlier detection as well as it is providing an option to give the healthy response. Okay, along with so the other option is TLS. So TLS is like we can set a specific certificate for endpoint termination. So let's say that I am setting up any external service. So that external service may be hosting some TLS certificate. So I can set TLS certificate here. Again, so connection pool setting. So we can set TCP or HTTP connections, timeout, maximum connection request, or max retries, what I told you earlier. Outlier detection, yeah, these are all settings of outlier detection, consecutive 5xx, or base ejection time, max ejection percentage, or all these things. So virtual service provides other options like some redirecting or rewriting or mirroring. Mirroring is send request to two endpoints at the same time. Okay. And rewrite is if my host is abcd.com, then there is option of rewriting its entire host with the entire URI. Okay. Redirect is instead of routing, you can redirect to another path. And header manipulation option is also there that it provides. A lot of slides here. So service A, service B. So here, so let me tell you here quickly. We are running just out of time, 10 minutes there. Service A to service B, version V1, version V2. So there are 2 headers. User agent is equal to Firefox and user agent is equal to Safari. So what I am saying that on my virtual service, if headers user agent regex, I'm using regular expression. If it's Firefox, then route to this service B on version V1, subset V1. Okay. And for any other routing thing, then route to service B. Okay. Or I could have explicitly said that if header, so these are OR conditions. You see, match. So this is a list. And all the component in this list is OR condition. If first one will match, then it would be served by first one. If not, then it will check the second one in the list. Likewise, it will keep on checking till the end. Okay. So here routing is taking place on the basis of match condition, and match condition is the header condition. This is straightforward. Okay. And like I told you, there are and or semantics. Let's say header name is x-debug. Instead of regex, I am saying no, it should be exact value dev. Okay. and. So these are two. So one is header, one is URI. Header is this, and URI prefix is this, then route to this. Okay. So this is making it the AND operation because both of these are at the same level. And this is OR semantic. Like I told you, if I'm passing both these two items in a list, then it has become the OR semantic. Header and URI both are now in parallel. Previous, both are now part of same list. Here, both are part of different list. So they become the OR semantics. And these are some timeouts, retry conditions. So let me, so this is the lab. So I'll walk you through the lab. We are having 8 minutes only. So let me be very quick here. Okay, so let us deploy. Okay. Get deploy. Let's see if version V2 deployment is here. No, customer V1 is only here. Let me deploy customer V2. K-f customer v2.yaml. So only one deployment is created. Okay, so customer V2 deployment is here, and I believe get pods. Its pod is up. Customer V1 pod is here. Customer V2 pod is here. Now come to the part. So I have checked both the pods. Destination rule. So destination rule, customer destination. So it is creating subsets. Name is customers. Okay, apply myself. Customers destination rule. So like I explained, destination rule has created the subsets. Okay, and for this customer service, okay, these two subsets, version v1 and version v2, and service name is customer.default.local. Okay, and let's apply the customer's virtual service. Service.yaml. Okay, so K get VS. So this is my customer's virtual service. Okay, and what it is exposing, customers dot a get VS this YAML. So what it is exposing, as of now, it is exposing only V1. Okay, like this. Now let's apply customer virtual service V2. So what my customer's virtual service V2 is doing, customer virtual service V2, no, customer virtual service final.yaml. Okay, so final is this. Let me see. So we have deployed. Okay, so let's put some load using the siege. So siege is saying okay, it is not giving me anything. Let me see what command. Siege delay 3 concurrency time gateway IP. Okay. So what it is saying. So okay, put some traffic and observe in Kiali dashboard that Let me cd istio samples add-ons. Okay, but it doesn't need this. So Kiali. Yes. So what Kiali is showing in the graph. So it is showing that traffic is only routing from to web front-end version V1 and customer V1. Okay. Now what? So you see only the V1 path here. Now let's shift traffic. Okay. Route to customers V2. Expose debug traffic to V1. Let's apply this customers vs debug.yaml. So maybe this is a smaller. Okay, apply -f customers v2. What was the name? Customers -vs -debug .yaml. Okay, so what is it doing? Customers vs debug. So this virtual service, it is saying that if your user agent header is debug, then route to v2 or otherwise route to v1. Okay. So as of now, our user agent, let's see. Okay, this is my web front end. Let's refresh it. And there must be some option of passing the header. Boom, boom, boom. Three dots, more tools. Okay, so instead of sending from here, let's uh, send header value to here. Oh, but I don't know how to set header value here. Is yes. Minus capital H. Header is equal to, what was the name of header? User hyphen agent. User agent is equal to debug. Okay. Now let's refresh Kiali. Give it some time. Should show. So what it should show is user hyphen agent. So it should show V2 for these debug calls, and it should show V1 for other calls. So user hyphen agent colon debug, and if I run this, output is going to come all the time. My header value is not properly set. So some issue is happening in passing the header. So what you will see, you are seeing a path from here ingress gateway to this. So there should be one more path from this ingress gateway to web front end version v2, and then it will point to customer v1. Okay. So web front end is again version v1, but here it will split it. It will split it like from web front end to v1 of customer and v2 of customer, because we have deployed two two versions of customers. Okay, like this. Some issue is happening with my header propagation. Okay, guys. Hello.
Yes. Yes.
So this is all about Istio. What we have covered Istio installation. We have gone through how Istio, uh, how different Istio components is working, and how spiffy thing is working, how the security context is working, the traffic management, traffic shifting. So this is the basic components of Istio. Okay. Any question?
Everyone, please feel free to unmute and ask your questions.
Hi, Nizam. Thank you so much for this wonderful session. I have one question. If the microservices are deployed in the Kubernetes environment and they need to interact with each other, then Istio will be able to route the request with the help of virtual services. And then, I mean, like, will it also play a role in the service discovery when these services are getting deployed so that there is no need of a separate load balancers?
Okay. So here are two things. One is when services within Kubernetes wants to communicate with one another, they don't need virtual service, okay? Because they know about each other automatically. If you give me 1 moment, I can show you that thing also, how services know each other. Let me kill it first. And let me take sleep pod, okay? So my Istio CPL
Unity shifts, baby.
proxy IstioOperator proxy config and CLUSTER clusters pod name.
Sorry, we cannot see if you're sharing your screen.
Oh, sorry, man. I disabled that. Okay, let me run this command again. So IstioOperator is a very wide utility used for Istio. So IstioOperator provides option proxy config. It's the short form. Then the clusters. So cluster nomenclature is used for the other services inside the mesh. So don't get confused this with Kubernetes cluster. Okay. So if we are creating a sleep service, so in terms of Istio, this is a cluster. We are deploying a web front-end service. In terms of Istio, all of its endpoints, or you can call it service, is a cluster. Okay. So I am listing you all the services. Okay. So I'm listing all the clusters which are available for this pod, sleep pod. So you see, these are some Istio specific. You see, this is the customers.default.svc.cluster.local. Okay, so this is one of your service that we deployed, right? And listening on port 80. This is the same service with version v1, same service with version v2. So it creates one cluster for every subset that we deployed of that particular service. Okay, let's say we deploy Grafana service exposing at 300. Okay, it is available inside this pod. I have not done anything. So all this information related to all other services which are part of the mesh is available inside this pod. Okay, and this information is passed to this job TOD control plane. Okay, so if this pod sleep pod wants to communicate this web.frontend, then this is locally available here. Okay. I can show you this web frontend. FUDN. Let me show you JSON. What is there inside one service? Okay. So you can see inside one service, this is all information related to this web front end. Like TLS mode is Istio and certificate. This is the service name and it auto. Now the load balancer policy is least request. Like I told you, there are circuit breaker things. We can tweak these circuit breaker things, and these are some metadata. Let me show you the routing rules for instead of web front end. Let's take here the clusters. Its name was customers because we applied some routing rules on customers. Okay. So what it is saying that this is subset B2 and 80. Okay. Why that thing was not working? Because we did not set the weight there, weight value. Maybe that was the reason. So like entire configuration. I am not contacting anything. I am only fetching the information what is available with this pod, the sleep pod, the sidecar inside this sleep pod. Okay. So your question was when service to service communication will take place, your sidecar has all the information of other services. It will automatically communicate with them. Even no third-party service discovery mechanism is required. Even no service discovery mechanism of Kubernetes of also not required, because Kubernetes manages a service registry of all of its services. Correct? But it manages its own service discovery mechanism within the sidecar. You have seen it.
Right. Okay. Makes sense.
Now, when it comes to your ingress gateway to any other service communication, again, ingress gateway is part of the service mesh, and whatever we have seen, the same configuration is available with ingress gateway. Now, here is the thing. If someone external to the mesh wants to communicate, right? So, of course, that component needs some external service discovery. Maybe we are exposing, that's why we are exposing via ingress gateway with this DNS name, right? With this DNS name, so that any external service, you are going to map this DNS name in your DNS system, like Route 53 or anything else, correct? So this way we can expose this to external world.
Yes, that makes sense. Thank you so much, Nizam. That answers, yeah.
Anything else? If you want to learn Istio, you will have to learn IstioCTL utility, because IstioCTL utility is must to learn Istio.
Right.
Because many times we need to see all this information, what all the clusters, the routing information, the endpoints, like the certificates or secrets, or a lot of things are there, right? Or the cluster state. So IstioCTL is a mandatory thing. So sometimes we deploy a configuration, but it is not applied. So how will you check it? How will you debug? IstioCTL is the only way. Okay. So yeah, I'm done here, guys. Thank you very much.
Thanks a lot, Nizam.
Thank you, Nizam,
Thank you
for that really informative session. I'm sure the participants have learned something new from this workshop. Everyone, please fill out the feedback form that's there in the chat box so that we can keep improving on our events. And if there are any queries you have about this workshop, feel free to ping us on the email thread. Looking forward to see you all at KCD Bangalore. Thank you everyone for joining.